Alright, so right at the start of this video, we can see that there are two kinds of nerve fibers, the blue one and the red one. The red one is covered by myelin. It's called an A delta fibers. They're covered in myelin, which helps them send signals really fast. They're the ones responsible for the very quick, sharp pain that you feel when something hurts you. The other one, the C fiber, or the one that is not covered by myelin, is having a signal that travels more slowly. It's the kind of pain that feels dull, burning, or achy, the kind that lingers after an initial injury. These two systems work together to help the brain understand what kind of danger your body is in and how urgent it is. We move into the different types of stimuli that can get detected. First is heat. The main players here are special protein in the nerve endings signals called ion channels. Specifically here, TRPV1, TREK1, and TRAAK. TRPV1 is probably the most well known. It's responsible for noxious heat, like temperatures above 43 degrees Celsius, and is also activated by capsaicin, the compound found in spicy chili peppers. TREK1 and TRAAK are potassium channels. They help stabilize the nerve's electrical activity and influence how easily a nerve fires. So when something hot touches the skin, these channels help you start the electrical signal that tells your brain, hey, this is way too hot for me. Next is cold detection. Here we see TRPM8, which get activated by cold temperatures or also substances like menthol, which is why it can feel cold on your skin or in your tongue. There is also TRPA1, which can be activated by cold too, especially in more extreme or pathological situations. Again, TREK1 and TRAAK play a role in adjusting how sensitive the neuron is to this kind of input. All these channels help translate a cold stimuli into an electrical message. Now let's look at acid, or more specifically hydrogen ions, or H+. When tissues become inflamed or injured, it is often becoming more acidic. That change is detected by ion channels like ASIC 1, 2, or 3. ASIC stands for acidic sensing ion channels. These are really important in inflammatory pain. TRPA1 also responds to proton. And again, TREK1 helps modulate how excitable the nerve is. So when you feel pain in inflamed tissues, like a sore muscle, this is part of what's going on. Mechanical pain, like pressure or pinching, activates some of the same potassium channels, TREK1 and TRAAK. These channels respond to stretch or deformation of the cell membrane. So when you push down on the skin, or if there is swelling that stretches the tissue, these channels help convert that mechanical force into a neural signal. Okay, now let's follow that pain signals as it travels to the brain. Once the sensory neuron detects pain, the electrical signals travels along the nerve fibers and enter the spinal cord through the dorsal root. There, it synapses, meaning it passes the message to a second neuron in the dorsal horn of the spinal cord. This is part of the spinal cord, acts like a relay station. From there, the signal travels up through the pathway called synophthalmic tract, eventually reaching the thalamus, which is part of the brain's central hub for sensory informations. And finally, the sensory cortex, where we become conscious and aware of the pain. At the synapse in the spinal cord, different neurotransmitters are released depending on the type of signals. So what happens when you actually get hurt, like from a cut? This injury caused the cell's area to break down and open and release a bunch of chemicals, including H+, an acid, which makes the area more acidic. ATP and more inflammatory molecules, these substances activates and sensitize the neuroreceptors. For example, those H plus ions from the injury can activate TRPA1. And the ATP binds to TRPV1, which makes the neuron more sensitive and more likely to fire even a mild stimulus. That's what we call peripheral sensitization. And it explains why injured tissue often feels extra painful.